So this is the extra credit video by Pouria Hosseini, and the lecture that I attended was Pattern Formation in Nature by Dr. Stephen Morris. So just a quick summary of what Dr. Morris talked about. The universe is not in equilibrium, and that's what makes it not boring. Stability, not optimality when it comes to nature. Nature wants to be stable, not necessarily optimal, and the experiment that I liked the most, of the ones that he showed, was the Maxi experiment. I'll talk more about that. So why is the universe not boring? Well, the universe is an open, driven, non-equilibrium place full of emergent patterns. For example, an example of these patterns is the primordial fluctuations. This is a look at the night sky. At the cooler and warmer regions of the universe is the heat left over from the Big Bang, and this lets us infer that the universe during the Big Bang was lumpy. It wasn't a smooth surface. Uh, so another thing that Dr. Morris stressed was that nature doesn't care about optimality. So there's no perfect balance of nature. It's a matter of stability. A question that Dr. Morris asked was, what do you think would happen if I start a straight river in this exact situation? Would it stay straight? And the answer is no. It would either correct itself and go back into the most stable form, or the erosion would cause a meander, which would then grow, and the river would continue to follow that instability and ride it to the end uh, until it reaches it's blocked off, or it just continues to erode and go through whatever it seems the most stable. So here are some examples of patterns here. This is up in near the Arctic, and so here you can see stones are arranged in rows or circles, and this happens because up there the ground will freeze and thaw every year, and every time it freezes or thaws, the rocks move just a little bit, and it's this freezing and thawing, and over hundreds of thousands of years, it's created these stripes that have sort of assorted the rocks by size. Some of the black stripes are the smaller rocks, the white stripes are the bigger rocks, and there's really no. We understand what causes this, but there's really no explanation as to why it happens. We know that it's the freezing and thawing that causes the motion or moves the rocks, but we don't know why they assort themselves. Same thing here with the circles, as you can see. Um, Another example of this was the Maxi experiment, uh, and this experiment was basically a thin sheet of glass, and different sized grains were poured through a funnel into this sand, and they assorted themselves into layers instead of falling in a uniform mixture, which is what you would expect. And there's no explanation for this, and studies have been done, and computer simulations have been done to find out why, but there's really no simple explanation. There's also another separation of grains called the axial segregation of grains. So here you put a mixture of small and large grains in a tube, and you just spin it over and over. And so after a certain time, they assort themselves by size into stripes. Again, this is not something that we can explain. Another example is Mima mounds. So Mima mounds, these are in North America. They're prevalent in North America, and we understand so little about these and what causes these that one of the up until recently, one of the leading explanations for this was shaking of the ground. The ground would shake up and down, and it would cause these. Um, Actually, right now, the leading explanation for Mima mounds is gophers. So you can see how desperate people are to try and find a solution, find a reason behind these patterns. But unfortunately, it's very difficult to see why these patterns occur. So what I learned during this experiment, I learned the most interesting fact to me was that nature is not optimal. It's stable. It goes for stability over optimality. Uh, Another thing is that emerging patterns are everywhere. I saw, patterns that I'd never seen before, like the pattern an icicle makes when the water flows over it and freezes at the end. It's more of a curvy shape instead of a straight shape, and there's very little explanation as to why these patterns occur, but they're all around us. And some ideas and concepts that were not discussed by the speaker. So I guess the only ideas and concepts that we really could apply to physics, as far as we've learned, is the momentum principle and the energy principle, and that weren't discussed in detail by the speaker. And although these principles don't explain why these patterns occur, but they are true in the occurrence. Energy is conserved, momentum is conserved, uh, and so these principles are still applicable even though they don't exactly explain this phenomena.